And this is what I felt from my personal communication with these people. And we are working we are using Hortonworks also in our professional versions. Are there open source versus enterprise versions? Do they have separate developer certifications? If yes, why? Yeah, Kamaljeet, each one of them have their certifications, but the Hadoop logic or MapReduce logic will remain same whatsoever the flavor you are looking for. Cloudera has its all on Cloudera developer certification. Hortonworks has its own developer certification, but the material or the logic to process the data and how the MapReduce work, how the pig and hive look like, how the pig and hive query will look like will remain same irrespective of the flavor. So by the flavor they are changing something at the back end. They are adding some particular things in the whole cluster. So when I'm checking out the cluster, it's not just the HDFS and Hadoop. There are different components also inside the cluster, like pig, hive, flume, Uzi, and things like that. So they are changing those things. They might be changing something on in the native implementation also based on their requirement, based on their optimization. Like Cloudera has added Impala and things like that. Hortonworks added Nox, Falcon, things like that. So they are adding other technologies in the whole cluster and making cluster usable for their clients based on their requirements. So this is how these flavors give different things, and you might choose a different flavor in your real lifetime example. But at the back end, how the HDFS works, how Hadoop works, how MapReduce works, how Pig and Hive works, how Scoop queries would look like, they will remain same in any of these flavors. Kamalji says 2 lines for Impala and Pass. Okay, Impala. Okay. Kamalji, just wait a sec. Are you able to see my another PPT? Are you able to my another PPT which is showing some architecture, Hadoop over MapReduce over Pig, Hive, and things like that? What happened? Just a minute. I'm just trying to share another PPT. Just give me a sec.
We could see your PPT when you have launched.
Okay. Now can you see it?
Yes.
Okay. But why I can't see my GoToMeeting? Okay, so these are how the technologies are sitting in this world. Over the MapReduce, there's something called Pig and Hive and Scoop, and people use these technologies to interact with reporting tools and BI tools. So these are the different things available in the market. They might be specific to a particular vendor also, but there are a lot of other technologies. I'll not be able myself also to explain all of them. The Impala, Kamalji, your question was about Impala, right? Somehow I am not able to see my, one second. Somehow I am, okay, here it is. Okay. Impala is something like Hive, but that helps you in memory processing, and as this is doing in memory processing, that is an expensive technology. So that gives you almost real-time results, because that is keeping your data in memory, and that gives you a processing power, something like your traditional data warehouses. Because when the table is small, and if I say select a star from so and so table, my results in the query would be in fraction of times. And same applies with Impala, as that keeps data in memory. rather than seeking the data. So that makes the Impala much faster, and that is from Cloudera. And
interesting. 50-second more. What is Zookeeper?
okay, Zookeeper is a coordinator of the cluster. So all of the communication in the cluster happens with the help of Zookeeper. So Zookeeper tries to maintain your whole cluster. I'll show you how the whole cluster looks like so Zookeeper helps you is basically doing the coordination across your cluster. So all this coordination, all this communication which I am talking till now is happening with the help of Zookeeper. So that's the reason Zookeeper is vertically placed on the left hand side in this slide. Any other questions before I go back to my previous slide? Kamalji says thanks. Okay. Okay. So there are native implementations, or there could be vendor specific technologies also which could have been implemented in the corresponding flavor. So you could see some changes, some differences over in these. The folder structure might change and things like that. But the native things like MapReduce, take, Hive, Spook, Poozy will not change. The command will definitely be the same. So let's see this, and then I think someone of you had the question. I think Kamalji had the question regarding. I forgot Kamalji's question, but that was related to this slide. I definitely can. Okay, yeah, that was how the name node works when the data is distributed. Yeah. So this slide, I'll try to explain you that thing what you were asking. So say this is my file. Which could be divided into 5, so which is of total size of 64 into 5 MB, 64 into 5 MB. So in the Hadoop word, HDFS word, the default block size is 64 MB. That's the reason I have mentioned it over 64. In Hadoop Yarn, I think it's 128 MB default. The block size is much higher compared to your other file systems like Unix or Windows, where it's 512 bits or something like that. The block size is very high. And after explaining this slide, I'll ask you the question why that block size is high. Probably someone of you could guess why that is high. In the meantime, so block size in the Hadoop word is very high, and your data is divided into blocks. So if my file is of size say 64 into 5 MB, that would be divided into 5 blocks, and these blocks would be placed in my cluster. And say this is how my cluster is looking like. This my cluster is looking like in this example. In this example, I'm just assuming that my cluster is only has one data center. There could be other data centers also, but in this example, I'm just assuming that my cluster has only one data center, and my data center has 3 racks, and this is how racks are looking like. And each rack is having 4 data nodes, or what I called commodity hardware till now. So, so this is how my cluster is looking like, and I have to put or copy this file inside my cluster. So what will happen? So this block 1, I'll try to put this block 1, and as the data is replicated and the default replication factor in the cluster is 3, so each block would be copied thrice in my cluster. And how that is done? The first copy of the block would be made randomly somewhere in the cluster, probably locally. I'll just come to that part what is locally. And that say is placed on disk 1. Then the second and third copy of the same block would be placed across somewhere in the cluster. And that is placed at disk 6 and disk 7. Does anyone want to answer a question why it has been placed on disk 6 and 7 and not on disk 2, 3 or 4? Kamalji says failover. Yes, that's perfectly correct answer. And the probability of whole rack going down in the cluster is very high as compared to 2 different racks going down simultaneously. And this is the way I replicate my data across the cluster. Each block is replicated thrice in my cluster. This replication factor is a configurable thing. I can change it to 5, I can change it to 10, I can even change it to 1, but that does not make sense in the Hadoop cluster because if the replication factor is 1, I'm not using the processing power of Hadoop and I'm not making the system reliable. But in development clusters, you can make that 1 to reduce your storage cost and to reduce the cluster cost. Why not put on 3 copies in 3 rack? Yeah, Rohit, I was coming to that question. Anyone want to guess why it's not placed in rack 3? So the 1 copy over here, 1 copy over here, 1 copy over here, somewhere in this rack, and 1 copy in somewhere in this rack. Okay, let me explain. So Rohit, I'll be explaining this question very much in detail when I'll be talking about the right anatomy of the system, but I'll try to explain it over here also. And we'll be talking about this thing in detail in the right anatomy of the system. So what happens up is, as I was more metadata in this case, they are placed in Abhijat says more metadata. No, Abhijat, metadata would remain same because somehow name node has to know that block is lying over here or here. The metadata information would just change the name, the disk name, and the quantity of the metadata would remain same. So Kamaljeet says IO time. Kamaljeet, can you please explain or throw more light on this point? So Kamaljeet, IO time. I think Kamaljeet, you are perfectly right. I'll just put you on air. I want you to explain to everyone. I think you are perfectly right what you are saying. Sorry, I muted you. I'm unmuting you.
As per my expectation, it is like writing within disk 6, 7 is within the rack 2, which would take lesser IO time rather than writing 1 copy in disk 6 and second copy in one of the disk of rack 3.
Yes, perfectly right. Yeah, that's a fair answer. So yeah, so IO or network, sorry, not IO, the network cost which is involved in transferring this data from here to here is pretty high, as the data transfer across rack is slower as compared to data transfer inside the rack. And if the data is transferred from here to here, it's much faster as compared to data transfer from here to this rack. And that is the reason the third copy is placed on the same rack to save this network time and save the network bandwidth users. However, the copies are placed on 2 rack under the assumption that whole rack is going down in the clusters, and the probability of that thing is pretty high as compared to 2 racks simultaneously going down in a cluster. Although 2 racks can go down in the cluster, but the probability of that thing is less, and this is the assumption that 2 racks will not go down simultaneously. If they have gone down, yeah, that's a disaster recovery kind of scenario. Moreover, if there would have been more than 1 data centers, Rohit says why 2, 3 copies. Okay, Rohit, I'm just coming to that part. Moreover, if there would have been more than 1 data center, then these 2 copies would have gone to some other data center also to maintain the reliability of the system across the data centers. So Rohit says why 3 copies? Why not 2 copies were enough? So Rohit. Okay. Just a minute. I'll explain your question in this slide. This slide talks about the architecture of the system, how your job is being processed in the system, and that will make you clear what makes the 3 copies in the system more fast as compared to 2 copies, and the number of copies more the number of copies in the system, more reliable and more powerful my system is. In these slides, I'll explain you that part. So once I'll be talking about how this whole system works, uses these copies to process the data, that will explain you. So Rohit had an answer that why in that case why I'm not putting the 2 copies only, and why I'm keeping the 3 copies. The default replication factor is 3. That could be reduced and decreased definitely, but at least 3 maintains not only the reliability but increases the processing power of the system. How? Just wait for some more time. I'll explain you that part when you understand this how this logic of processing the data happens in the cluster. So Kamalji said one of my previous question is the data to be stored by reasons like Google stores data across the world. How big data architecture works in such a situation. So this is what happens, Kamalji, in that scenario. The one copy of your data would be lying in one data center, the other copies would be lying in other data centers, and name node knows where your data is lying. And when you request the data, name node will try to find out local data for you. That is, if you are sitting in data center X and there's a copy lying in the data center, it will return you the address of that node in that data center, and you can copy or get the data locally rather than doing a network communication across the data center. And if you are sitting the same rack where the data is lying, it will definitely return you the same address of that rack. And if you are sitting on the same data node, it will definitely return you the local node where the data is lying. So this is how the data which is replicated across data centers is being communicated or used across the cluster to get the information about the data and reduces the network bandwidth used across the cluster. Now, does that answer your question, or still you have some other confusion? Kamalji says yes. Okay, that's great. So guys, I understand you would be having questions. Keep on asking me questions. If those questions would be cleared in next slides, I'll just say you. I'll be clearing it to next slide. And if by mistake I forget when I'm coming to that slide, just ping me that question again so that I can recall that. So Rohit, just bear with me for some more time, and I'll answer your question also. Why 3 copies and why not 2 copies were enough? Although even a single copy would have been enough, but that would not have given me the reliability and the processing power as compared to 3 copies. How? Just wait for some more time. And or for the next class, because looking at the time, we might not be able to cover that whole thing in this class. But definitely, I'll answer your question. Just recall me when I'm on those slide number 37, 38, 39. I'll answer your question. So guys, so now let's say I have to put another block. So the first copy of that block would go somewhere. Say it's gone to rack 2, disk 6. Now I want a quick answer from everyone where the second and third copy of block 2 would go. Kamalji says rack 1 or 3. Akash also says either rack 1 or 3. Yes, that's a perfectly correct answer. It might go to any one of the rack, but it will not go to both rack 1 and rack 3. That's the correct answer. And the reason behind that is to save your network cost. And same will happen to other blocks also. So same will happen to other blocks also, and it will keep on copying this whole file to the system. So a file is divided into blocks, and these blocks are copied, and these blocks are really replicated. It's not your whole file which is replicated. These blocks of the file which are replicated, and this metadata information is maintained on the name node. So what I was saying in this slide was, where it gone? So files are broken up into blocks, typically of 64 MB. Each block is replicated on multiple data nodes. I hope now this point is clear to you. And this all we have talked about. Single namespace for the entire cluster, data coherency, write once, read many times, intelligent client, client can find out the location of the blocks, and so in that case client just communicate with the name node, and name node returns the location of the block, and client directly communicate to the data node and get the location of that block. Is that clear? Other than the Rohit, your question, I'll talk about that. Any other questions? Okay. So I assume everything is fine. I'll just go ahead. So we have just seen this block placement strategy. One replica on the local node. By local node, what I mean to say is, say I as a client, Akash, okay, Akash says Y64 MB. Okay, so as Hadoop is dealing with large files, and as I was saying previously also, the seek time to find the data is very high. So to reduce this seek time, they chose to keep block sizes high. So to seeking, so as I'm traversing high block sizes, my seek time is reduced rather than looking into individual smaller block sizes. So this high block sizes reduces in the seek time of the system, and I just read this whole block and process the data. So this high block sizes basically helps me in reducing the seek time of my system. A small block size is also, yeah, that is also one of the reasons. A small block sizes will result in high amount of metadata also, but large block sizes also help me in reducing the seek time of the system. So we have seen one replica on local node, second replica on a remote rack. By local node, I mean I was saying that say I as a client running on this, sitting on this machine has this Hadoop infrastructure installed, and this is one of the commodity hardware of this whole cluster. I as a client sitting on this on this machine, communicating with the help of my Unix system and communicating with the system. So when I will be requesting the name node, hey man, I have to copy this file somewhere, do let me know where I can copy. So that name node will intelligently find that this data node has some capacity, and if this data node has some capacity, the first place where the address which name node will return to copy this block would be the local node. And this is how a name node tries to reduce, or the cluster or the infrastructure on the whole framework tries to reduce on network bandwidth as well as possible. So that is what I was saying over here. The local node, one replica on the local node, second replica on the remote rack, and third replica on the same remote rack, and additional replicas randomly placed. And clients, when and same applies to read also. When client says I want to read something, the name node intelligently finds the nearest replica for you and tries to return that replica. Okay. So now all of these things I've covered in much detail in my previous slides, and I hope that is all clear. Large main property of LTFS file system: large block sizes, the file sizes are large, the application factor, failure is normal, normal scenario, fault tolerance, and if something goes down, the automatic recovery happens with the backend. How that happens? So say my data node, which is having a copy. Oh, 1 minute. Let me share an Excel sheet. Just give me a sec. Something strange is happening. Just a minute. I'm not. Okay. I think sorry, there's something strange happening with this person. So I really forgot what I was saying. Okay, how the fault tolerance happens. So I hope everyone can see my Excel sheet. If you are not able to see, just ping me on the chat window. So what happens when your data is distributed across a cluster in the data nodes? So say I have to copy the file which have 5 blocks in it. I'll be copying it to two different data nodes. Say this data node is one copy of block 1, copy of block 2, and copy of block 5. Say this data node is copy of block 2, copy of block 1, another copy of block 1, and copy of block 3, and say copy of block 5, another copy of block 5, and say this has 4, and so on. I am just something like that. Now, if say this data node goes down in my cluster, so these data nodes keep on sending heartbeat signals to your name node. And this heartbeat signal is sent at a particular frequency of time. And if name node has not received that heartbeat signal from the data node, it will safely assume that that data node is down. And if that data node is down at the back end, this data is replicated across the cluster for you. So this, so in that case, what this name node knows is now the copy of block 1, 2, and 5 of file F1 are missing, and that need to be replicated to some other data nodes to maintain the replication factor of 3 in the cluster, and that is done at the backend for you. And this is how your system is maintained, or the redundancy factor in the system is maintained. So this is how the fault tolerance happens, automatic recovery happens in the system. There are other factors also. We'll be talking about them when we are talking about the task tracker and the job tracker. Rohit says, and if the data node comes back, it will adjust. Yes, yes, definitely it will adjust. So now you understand all this thing. There's something called name node, there's something called data nodes. This all are data nodes, and the client, when I start to read something, it will just request for the metadata about the data from the name node and read it from the corresponding data node. These blocks are these green things are the blocks, and these yellow things are your data nodes, and these are your racks, and the data is replicated in the blocks across your data nodes, and the name node at the backend keeps on communicating with these data nodes to maintain the system. Do I have any chat? Yeah, okay, that was from Rohit. Now these all things are just cleared in my previous slides. So name node maintains the metadata in memory. That is the list of the files. So now you understand how the name node gets the list of the files. Whenever I have to copy any file, first I have to communicate with the name node to get the location where this file need to be copied. So this is how name node knows which are the files existing in my system. List of the blocks, again the same logic. I have to ask all these information from the name node where to put these blocks, and this is how name nodes knows the list of blocks existing in my system.